Hi everyone, welcome to my channel. What if an entire nation could build a wall against the sea, but design it to breathe?
Not a solid wall, not a dam that permanently blocks the ocean, but a colossal machine capable of opening. This is the Oosterschelde Barrier, one of the greatest achievements of the Dutch Delta Works and one of the most extraordinary engineering projects ever constructed. The Netherlands has always lived in a delicate relationship with water. Much of the country lies at or below sea level, protected by dunes, dikes, pumps, canals, and barriers. For centuries, the sea provided trade, food, and prosperity, but it also brought destruction. After catastrophic flooding demonstrated how vulnerable the region could be, Dutch engineers began developing a new generation of coastal defenses. Their challenge was enormous: protect communities from deadly storm surges without permanently destroying the tidal ecosystem of the Eastern Scheldt.
The answer was not simply to close the estuary, the answer was to control it. Before any permanent structure could rise above the water, engineers first had to understand the seabed.
Survey vessels mapped the underwater terrain, studied tidal currents, measured soil conditions, and marked the exact alignment of the future barrier.
Marine work platforms, barges, cranes, and specialized vessels were then positioned across the construction zone. Temporary working islands and logistics areas supported an operation taking place in one of the most demanding environments imaginable. Every stage had to fight moving water, strong currents, changing tides, salt exposure, wind, and unstable marine ground. The seabed was carefully prepared. Weak material was removed or stabilized.
Foundation zones were leveled with extreme precision.
Filter layers were placed to prevent soil from washing away, followed by heavy armor rock designed to resist powerful currents and future erosion. These layers were not merely supporting the structure, they were protecting the entire foundation from being undermined by the sea.
Then came the enormous foundation units and concrete piers.
Massive prefabricated elements were transported across the water, carefully aligned, and lowered onto their prepared positions. Even a small error could have disrupted the geometry of the complete barrier.
Once positioned, the foundations were secured and connected.
Reinforcement cages rose upward, steel formwork surrounded each new pier, and concrete was pumped, placed.
Inside the temporary enclosure, temperature sensors and circulation systems helped manage the heat generated as the huge volume of concrete hardened.
Samples were extracted and tested. Only after the concrete achieved the required condition could the temporary systems be shut down.
Hoses were disconnected, sensors were removed, thermal insulation was stripped away, and then, panel by panel, the steel formwork was released.
For the first time, the finished concrete pier emerged from behind its temporary shell.
Every exposed surface was inspected. Small imperfections were cleaned, repaired, finished, and protected. The result was not simply a concrete column, but one component of a precisely aligned system stretching across the tidal channel.
Across the project, the same demanding sequence continued until a monumental line of reinforced concrete piers stood in the sea.
Between them, enormous movable steel gates were installed.
These gates transformed the project from a static barrier into a controllable defense system.
During normal conditions, they remain raised, allowing seawater, tides, marine life, and vessels to move through the openings.
But when a dangerous storm surge approaches, the gates descend. One by one, the open passages disappear. The sea is no longer free to push inland. The barrier becomes a shield. Completing the structure required far more than concrete and steel.
Hydraulic machinery, electrical equipment, sensors, maintenance galleries, access roads, control systems, Every mechanism was tested. Every gate was moved through controlled operating cycles. Every guide, seal, connection, and hydraulic system was inspected before the barrier could enter service. And then, after years of marine construction, the temporary platforms, cranes, barges, scaffolding, and working equipment disappeared.
What remained was one of the most powerful machines ever built at the boundary between land and sea.
In bright morning sunlight, maintenance vehicles move along the permanent service road while the gates remain open beneath them. During the heat of summer, technicians inspect exposed equipment to ensure that every operating system remains ready.
At sunset, permanent lights illuminate the long line of piers.
At night, inspection vehicles travel through wind and rain, while tidal water continues flowing below.
And when the North Sea becomes violent, the Oosterschelde barrier reveals its true purpose.
Winds intensify, waves grow higher, and the control system prepares the barrier.
The giant steel gates begin to descend between the concrete piers.
As the final openings close, the barrier stands between the storm and the protected land beyond it.
On one side, powerful waves strike the structure. On the other, the water remains visibly calmer.
After the storm passes, the barrier is inspected before reopening.
Machinery housings are checked, hydraulic systems are verified, and gates are gradually raised. Tidal exchange returns. Inspection vessels pass through first, followed by normal maritime traffic.
Maintenance teams continue their patrols, and the barrier returns to silent readiness.
This is what makes the Oosterschelde storm surge barrier so remarkable.
It is a structure built from concrete, rock, steel, and hydraulic power. But more than that, it is built from precision, patience, and deep respect for the forces of nature.
The Netherlands did not simply build a wall against the ocean. They built a system that knows when to let the sea pass and when to stop it.
An engineering masterpiece that stands as an eternal guardian of the Dutch coast.
As the sun sets over the estuary, the barrier remains on watch, safeguarding the shores below.
This legacy of innovation continues to inspire coastal protection projects across the globe.
Engineers constantly monitor rising sea level projections to adapt defense strategies for tomorrow. Proving that humanity and the sea can coexist in a delicate, engineered harmony. Tested by decades of harsh gales, the barrier stands as an enduring monument to human ingenuity. From an impossible vision to a living shield, this is the story of a nation that learned to command the tides. Some structures are built for convenience, while others are built for survival. The Oosterschelde barrier remains an unyielding defender of the Dutch heritage.
A true masterclass in civil engineering, hydrology, and environmental preservation.
Behind these gates, millions of lives, homes, and histories continue to flourish safely.
Standing tall against whatever the future ocean may bring.
Proof that when humanity faces impossible odds, vision and science can build a path forward.
Because when you respect the water, you learn how to master it without breaking it. This is the incredible legacy of the Dutch Delta Works.
Thank you for watching, and make sure to subscribe for more stories of the world's most incredible engineering marvels.
Until next time, keep exploring the hidden wonders of human innovation.
Goodbye.